This lesson is on the slope of a line. This is section 3.2 in your textbook. The essential question for this lesson is, what is slope, how do you find it, and how do you use it? Slope has many practical applications. Basically, it is defined as steepness. So you might have the slope of a ski slope, how steep it is, the grade of a highway, but these all are related to slope or steepness. Mathematically, however, we do have a formula for slope. So in math, we often refer to slope by the letter lowercase m, and that's equal to rise over run, or if you're talking about a graph, it's the change in y over the change in x, or more specifically, if we're talking 2 points, y2 minus y1 over x2 minus x1. So let's look at a specific example. Let's say that we're asked to find the slope of the line through the points 2, minus 1 and minus 5, 3. Now it doesn't matter which set you set equal to x1, y1 and which set you set equal to x2, y2, just so long as you're consistent with one of them being point 1, the other being point 2. So using the formula we learned above, we can say that m is equal to 3 minus a minus 1 over minus 5 minus 2, or specifically positive 4 over negative 7, or minus 4/7. So that's the slope of the line passing through those 2 points. Now a couple things to be careful of when you're doing this is, first of all, that you use the formula correctly, and that you subtract the y values and the x values in the same order. But probably more important than anything else is, be careful with negative signs. Make sure you don't make a sign mistake whenever you've got a negative sign. For example, in our example, we had 3 minus a minus 1, which is actually 3 plus 1, or 4. So be careful of your negative signs, and be careful that you're subtracting in the correct or in the same order for both x and y. Now let's say we want to find the slope of a line given the equation of the line. Well, there's a couple of things you could do with that. First, you could find 2 points on the line and then proceed as we did in the prior example. Or the other way is to simply put the equation in y equals mx plus b form, and then you could read it right off the equation, since m would be the value of the slope. So for our example, let's assume we're asked to find the slope of the line 4x minus y equals minus 8. So as I said, you could simply make a table and find 2 points. Preferably, though, I like to take and convert this to y equals mx plus b form, and then you can read it right off from the equation. So if we start with the equation, 4x minus y equals minus 8, and the first thing we're going to do is subtract 4x from both sides. That leaves us with minus y equals minus 4x minus 8. Then we're going to divide by minus 1 to get rid of the minus in front of the y, and that's going to give us y is equal to 4x plus 8. Now, this is very easy because now we can simply look and realize that the slope is 4. The y-intercept is 8, but all we were asked to do was find the slope, so we know m, the slope, for this equation is simply equal to 4. Now what if we had very specific lines, like either a horizontal line or a vertical line? Well, we could pick points and calculate the slope and verify what it is, or we could simply realize that. So if we had a horizontal line, the slope would simply be 0, and if we had a vertical line, the slope would be undefined, okay? So that's something you really need to remember, is that the slope of a horizontal line is 0, and the slope of a vertical line is undefined. Slope can also be used to graph a line. For example, if you have the slope and at least one point, you can graph the line. Let's look at an example. So let's graph the line that has a slope of 3 and a y-intercept of 0, minus 4. So let's start by locating the y-intercept. The y-intercept is at 0, minus 4. So that location is shown by the red X there, okay? So now we have a slope of 3. It's positive 3, so that means we go up 3 and over 1, which puts the second red X there at coordinates 1, minus 1. Now if you connect the points with a straight line, we have graphed our line by using simply the slope and the y-intercept. Remember, we picked the y-intercept first. We found that it was at 0, minus 4. Then we had a slope of 3. Remember, it's change of y over change of x. And since it's positive 3, that means we went up 3 and over 1, or up 3 for the y and over 1 for the x, to give us the second point, connected the 2 points, and that gave us the line. Now, if our slope had been negative instead of positive, then we would have started by going down first, whatever the numerator was, and then to the right. So if our slope is negative, we could go down y and then to the right x. If our slope is positive, we go up y and to the right x. Now let's talk about slopes of parallel lines. Now, if you think of it, parallel lines are in the same plane but don't intersect. So if you were to look at the slope of one of these parallel lines and the slope of the other parallel line, you would realize that the slope or steepness is the same on the two parallel lines. Therefore, the slopes, the actual numerical slope of parallel lines, are equal. Okay, so if we have two non-vertical lines with the same slope, they are parallel. So now, what about the slopes of perpendicular lines? Okay, obviously these slopes are not equal, but what are they? When you've got two lines that 90 degrees, form an angle of 90 degrees. Well, in this case, these slopes are negative reciprocals of each other, okay? Another way of looking at it is that their product is minus 1. However, a more simplistic way of looking at it is, if you have the slope of one line and you want to know the slope of the line that's perpendicular to it, you flip it, in other words, get the reciprocal, and you change the sign, and that will give you the slope of the perpendicular line. So there we have it. The slopes of parallel lines are equal. The slopes of perpendicular lines are negative reciprocals of each other.